I'd like to start off just by doing a little survey. Who saw the title of this on Meetup and thought, well, that sounds interesting, I might learn something from it? Just chuck your hand up if you thought something like that. Keep your hand up. I'm just going to ask a couple of you what you thought you might learn. So,
I thought that probably you processed a lot of data and maybe you have better organization of your microservices API. Yeah.
Thanks. I think you had your hand up.
I did. I thought I'd learn something about Tyro. I thought I'd learn perhaps like a contrast before and after sort of picture.
Yep, thanks. Someone else? There were lots more hands up. Brilliant.
Thought maybe there will be some lessons to learn from the challenges that you guys been through. So I think that's worthwhile.
Yep, excellent, thanks. So I'll cover most of that. I don't think I'm talking much about data, unfortunately. But maybe someone can come and do that in the future. So I love surveys. I'm going to be talking about this stuff. I'm going to go pretty fast, so lots of stuff. I'll go shallow, and there'll be time for questions at the end if you want to find out more about something. But surveys. Can you put your hand up if before this talk was announced you'd never heard of Tyro Payments? Okay, thanks. And put your hand up if you had heard of it before. Thanks. And now just keep your hand up if you'd only heard of us before because a recruiter contacted you. Okay, I've got to have a word to our recruiter because they should have talked to all of you. So even though you may not have heard of us, you might have actually used our services. We do FPOS. These are some of our unique looking terminals and our customer receipts. There's a lot of them around the place. Often people who join us a couple of weeks after they've joined us say, oh, my doctor uses Tyro. I never even realised I've been using it all this time. What Tyro does is, in the finance industry, technically called acquiring, but you might call it payment processing. And so basically what we do for merchants who are our customers, the people who pay us money, we provide them connections to a whole bunch of different ways for their customers to pay. So we connect them to international card schemes, the domestic FPOS network. We also connect them to Medicare and private health funds and some gift card partners as well. So we're writing a lot of stuff there. There's kind of real-time connections and there's batch processing and integration with the RBA because that's how the money moves around. We don't make the hardware, but we do write the application software that runs on the terminals. We don't write point-of-sale software, but we do integrate with hundreds of point-of-sale software vendors. In case you're wondering, we're not a bank. We're a financial services company. We're not allowed to take money on deposit, so while we process millions of dollars each day, that money all comes into our system, and then we pay it out straight away again. Yeah. So I'll cover just briefly why we do microservices. This topic's been done to death, but I think, if you get our view, that might help with some of the things I'll talk about later. So I think the key thing is business agility. Something we all know about software agility these days, the opportunity for software teams to kind of change direction quickly and experiment with new things. And business agility is the same thing, but for the business. You want to enable the business to be able to try new things, to be able to move into new places quickly. And I think that's the primary reason that we're doing microservices. If you want to know more about business agility, I can recommend this book called The Phoenix Project. It's about DevOps and the theory of constraints, but it's really about the same thing, about getting business agility into a business. It's about decoupling. Microservices is about decoupling. I think that's the main technology advantage. And decoupling things makes change less risky and also makes change easier to deploy. Decoupling also leads to service autonomy. And we think about service autonomy because we want the services we build to be responsible for achieving their business task. And in general, to do that, they need to be able to kind of integrate with as few other services as possible. So decoupling and autonomy work together. And then that plays into system resilience. So once you've got a system that's built of autonomous services, your system should become more resilient, because if part of that system goes down, the other parts, in theory, should be able to continue doing their job. Is it about productivity? Maybe yes, maybe no. I think with microservices you end up with smaller code bases, and that's going to be a good productive win for your developers because, the bits of software they're working on will be easy to understand. But then you've also got the distributed computing aspect, which means there's a lot more things to consider that if you're putting everything into, one memory space, you wouldn't have to think about it all. So I think there's pluses and minuses there. Perhaps long term, you'll end up with a productivity gain from microservices. If you're hoping to do microservices for some productivity gain in the short term, it's definitely not what you're going to get. It's of course not a silver bullet. It's to solve a set of problems, but it brings a set of problems with it that are different. And microservices is most definitely about hype. Personally, I think as an industry, we're probably at the peak. We're starting to see the books and the blogs flow out and everyone talking about it. At Tyro, I'd say we're seeing some challenges, and so we're kind of on the way down the trough there. We know there's lots more challenges to come. I wouldn't say that we're put off at all. We're going to keep pushing through to that plateau of productivity. But I think it's interesting that different organisations and even different teams within an organisation can find themselves at different points in this hype cycle. So you might find one team's really only just getting started with microservices and they're still excited and doing new things, while some other team might have been doing it for a year and they found all kinds of problems and they're kind of down here and basically bitching about it at lunchtime. But you can use that to your advantage too. If you can get those teams talking, they can learn things from each other, and maybe some of the vitality of the people who are still hyped can play off on the other guys. So Tyro's architecture history is interesting. We basically have a distributed system that has evolved. So just before I joined, everything in Tyro was in one application. That was the server for the terminals, the public-facing merchant portal, the private back-office web portal, the batch processing, the integration with the settlement systems, all in one application. So some of that had been separated out, and at the time I joined, we're in the process of separating all the other things out. We're actually doing that for regulatory reasons. We wanted to get PCI DSS certified, and we had to have an N-tier architecture in order to protect our systems. That was the driver at that point. But we continued adding new features, and as we added new features to the system, it seemed to make sense if there was a big new responsibility to put it in another application rather than throw it in with all this other stuff. And so we did that, and that worked well. Though we did often, we had one component that stored data and did batch processing. So we tend to put kind of the real-time aspects in their own new little server, but then we'd throw all the data into one place as well. And that place has become our monolith, and it's still around today. I'll talk about that a little bit. But we've definitely enjoyed the benefits of that decoupling that we did. So for example, at one point we went from having one transaction switch in one data center to having 4 transaction switches across 2 data centers. And we're able to do that pretty simply because it was already decoupled from the batch processing. We didn't have to think about how to do that separation or how to do redundancy of the batch processing or that kind of thing. So it's definitely had benefits for us over time. Like I said, we have a monolith. I think we've done an okay job of keeping it from being a big ball of mud. There are definitely bits that are mud, but there's lots of bits that are kind of in really tight components and have APIs that kind of separate it from the other components, and it kind of stops things from getting too linked into each other in the same way that microservices is meant to by having those distributed interfaces. We're actively splitting stuff out of that, and I won't talk much about that because that's a whole nother talk, and there's other people better qualified than me to do it. But I will say one thing about it, which is we've used a risk-based approach to decide what to split out of that monolith. So we looked at the monolith and we said, if this monolith fails, what will the business be most annoyed about that that bit isn't working? What is the thing that's the biggest threat to the business if this thing isn't working? And so we identified that component. We said, that's the thing we're going to pull out first. We're going to pull that out so if the monolith fails, that thing can still do its job because that's the most important thing. And that's actually been really good because when we say to the business, we want to do some refactoring, we want to do a big project, we want to change the software, and in the end it's going to do the exact same thing, they're like, huh? But if we can say, at the end, if a big part of our software fails, we'll still be able to do this really important thing. They're like, oh, okay, I see the value in that. We've got this thing on our risk register that's right up near the top right, and you're going to kind of bring it down a bit, and, points for that. So if you're thinking about splitting the monolith, think about how you can get a business advantage out of that, not just a technological advantage. Over the last 12 months, we've become much more aggressive about how we are doing microservices, and in particular how we're avoiding putting new stuff in that monolith. So if you kind of suggest putting anything in the monolith, you should expect for people to come at you with clubs and take you down. The result of that has been we've deployed 14 new services to production in the last 7 months. It's an average about 1 every 2 weeks. And we've got another 18 in our pipeline. Hopefully we're getting more rapid at deploying them, so it's not going to take us another 6 months to get them out. I wanted to show you our architecture, but unfortunately the VP of Operations didn't really want me to take a map of our system and put it in the public domain for people to kind of figure out how they can get in and have a surf around. Not that they should be able to do that. All kinds of protections, but, defense in depth. He didn't want that public knowledge. But here's a fake architecture I made together with the assistance of my 5-year-old. I placed some of the arrows just to make sure it was completely random. So it's got about a similar number of services to what we've been building over the last 12 months, and a similar number and type of connections. So you can see there's things connected to the internet and third-party services. Lots of stuff going around with REST. We're also using RabbitMQ for asynchronous communication. And we do that in 2 flavors. The orange ones are things we call commands. So it's basically, this service telling that one to do something, but it's doing that asynchronously. And the green ones we call events. So that's basically a service saying, this happened in my domain, and other people can listen to that, and he doesn't know who's listening or what they're going to do. It's a broadcast, essentially. Another thing worth mentioning at this point is this is a logical diagram. So we run everything redundantly. Like I said, we've got 2 data centers. So every service on this thing is running at least 2 instances in production. If it's really important, there's probably 4. So that can make things kind of complex. We also deploy this software every 2 weeks. So anything that gets changed, every 2 weeks we release it and put in production. And we do that during business hours. So we have kind of some design constraints there. And we do that intentionally. We've designed the system so we can upgrade it during business hours. Because ops people are awake, and if something goes wrong, devs aren't going to get woken up to fix it. What does a Tyro service looks like? Well, it's going to be pretty boring to some people. Almost everything's written in Java. Almost everything is on top of Spring. We're deploying on Jetty. We use the metrics library written by Coda Hale, now part of DropWizard. If we're doing REST stuff, we're using Spring MVC to implement that. We're using RabbitMQ to do messaging. If we're talking to a database, it'll be Hibernate or JPA. And we build all of those things with Maven. I'll cover some of those a little bit. I'll talk a bit about the Maven stuff. I want to talk about size just briefly. Some people say microservice is about having aggressively small applications. And personally, I think lines of code is a terrible measure of what a system is doing, but I thought I'd show it to you just in case you're interested. So this is just the things we've made in the last 12 months, the number of lines under source main. So they're not necessarily Java. There'll be Java in there, there'll be import statements in there, there'll also be properties files, Spring configuration, all kinds of things. The one at the end is a web application that someone has imported jQuery and Twitter Bootstrap in as source. So the majority of that is actually not our code at all. So the median here is somewhere around 2,500 lines. You can see most of them are 5,000 lines or longer. But I think when people are trying to talk about that, I think what they're really trying to talk about is complexity. And I thought maybe a better way to think about complexity would be the number of classes in an application. So this shows a number of .java files in each thing. So you can see the majority of them are under 50 files, and the median somewhere around 25, 30. So if you organise your code well, and we do, think maybe about 6 packages within a service, you have about 5 classes in each of those packages. So you think about opening up a code base and you see 6 directories with 5 files in each. That's a pretty simple thing. You can be able to understand most of that in half an hour and surf your way around and figure out the whole thing. Some people might look at this and think, hey, that's not microservices. Microservice means, your whole service fits in one file and you can print it out on an A4 page. And that's what micro really means. And maybe they're right, maybe they're not. I don't really know. But I think context plays into that a bit. So we're in a financial services environment, and that means everything has to be guaranteed. We also have to guarantee nothing gets done twice. We also have to audit absolutely everything that happens. And we design pretty much everything for 100% uptime. So all those non-functional requirements end up as code, as you know. So you might be writing a website with web services and you don't have to think about any of those things. And you can write your whole service in a page and it all works brilliantly. But for us, life is a bit more complex. Having said that, there are a couple of things here that are only between 2 and 5 classes in the whole service. There's actually one here that has 0 source files, 0 Java source files, and that's a service in production and running. So the whole thing is bringing in libraries and wiring them together with some configuration. That does something useful that runs in production. So I'll talk about some practices now. We've got 9 teams working in this microservices environment. So it's important to have some rules and guidelines and practices and things like that. So sometimes those things are there to protect us. Sometimes those things are there as a strategy to win. And they're all kind of there as something to help the team keep moving together in the same direction. One artifact is one primary responsibility. So this is, if you've heard anything about microservices, you'll have heard about this. And the way we're cutting things up is as business responsibilities. So we're not trying to create, really generic reusable services like a unique ID generator that you call over the wire or something like that. We're cutting things up by business responsibilities. So if that thing's running by itself, it's going to do something useful as far as the business is concerned. Artifact naming is really important, and we name them after our responsibilities. So the rule we go for is that the name of an artifact should answer this question: what is this artifact responsible for? So if you say, what is this artifact responsible for, and then you say the name of the artifact, it should accurately answer the question. So I'll give you an example. This is just one I made up. Private Health Commission Payment Reports. So it's pretty clear what's it responsible for. It's responsible for Private Health Commission Payment Reports. Now, on the other hand, if you just call that thing commissions and said what's it responsible for, you don't know. Is it responsible for paying the commissions, receiving commissions? Does it report on them, or does it actually action them? You can't tell. Something else we do is we avoid words like service and server and application, because they can kind of tart something up but without adding any information. So commissions service sounds a bit better than commissions, but it doesn't tell you anything else. So we don't put words in there like that. I think I'll give some advice if you're making services, is to take the name of the service you're making and go to someone who knows nothing about what you're working on and ask them what they think the responsibility of the service is. And if the answer they give you doesn't make sense, maybe you need to think about the name of your service again. Data ownership is essential, I believe, in microservices. So data needs to be owned in a single place. We don't integrate any services through a database, and we don't let 2 services have editable versions of the same data. They don't have editable versions of the same data. At the same time, data duplication is okay. So it can actually be really good to cache a small amount of data from another service in your service, because that is an enabler for autonomy. If you need that bit of data to do your job, but you need to talk to the other service to get that data, then you're creating a dependency at runtime. So if you can cache that data instead, you can be more autonomous. There's a catch though, and that is that if you're doing that caching, you're going to end up with eventual consistency within your system, because you're probably going to get that data over asynchronously. So sometimes, if the network's not working or that service went down or whatever's happening, your data is going to be out of date. So if it's important for your service to have the absolute latest data, you can't do that caching. You have to go over and get the latest thing from the source, the place where it can be changed, the place where it's owned. And doing that makes your system less resilient because you've created a coupling at runtime. And at that point, I say, hello, CAP theorem, because it's not exactly CAP theorem. You're not writing a distributed database, but you have made a decision between consistency and availability. So if you're happy to have a cached bit of data that might be a little bit out of date, then you're sacrificing your consistency for some availability. But if you need to go to that source of truth, you need the consistency, but you're sacrificing the availability. So you need to think about those things when you're thinking, where's data going to live and how am I going to access it? We use common communication methods, something pretty much everyone recommends. So we have a small number, basically the REST and the rabbit is all we do. We have common libraries that make it really easy for people to use those things, and they include some of the patterns that we do around redundancy across multiple servers and things like that. So it makes it easier for people to get things right. We have some shared architecture diagrams. So as you can see, the system gets pretty complex pretty quickly. The diagram doesn't actually look like that anymore because it got too complex, so we split it out into 10 different diagrams based on kind of different features of what we're building at the moment. But we allow people to go in and update the architecture so that everyone can see where their system is in this whole system and understand how the whole parts fit together. Artifact briefs are another tool we have for people to help other people understand how the system's working. So an artifact brief is a one-page summary of a service. So it lists its responsibilities, just in bullet points, a couple of lines. And it also talks about what it stores in that service and also who it connects to and usually for what reason it's connecting to. If it's got any special security requirements, like it's encrypting certain data, it'll do that as well. It also lists the developers that originally created that service. And the reason it does that is because there's not all the information on that page. So if someone from test or ops wants to talk to the people who created that service, they can go to this page on Confluence, say, go and talk to this team, and I can get some answers. Parent POMs, archetypes, and scripts. So we're using Maven. We use parent POMs so that we don't have massive build files everywhere that diverge from each other. Instead, we define most of our build in one parent POM, and the POMs for our actual artifacts are quite simple, and we define everything in one place. So lots of our builds are standardized. The archetypes and scripts pretty much allow us to create a new service in a couple of seconds. So the archetype will create an application that has everything we expect in an application, put the port numbers in as part of the script so the thing can run up instantly. And it's also put into source control and put into Jenkins continuous integration. So within a couple of seconds, a team can make a new service and it's building on Jenkins successfully, and they can start adding code for it to do something useful. Scrum of Scrums. So we've got a project at the moment that has 6 teams of 7 people, and they're all coordinating quite a lot. So to ensure we coordinate well, we recently started doing Scrum of Scrums meetings, so the team leaders of the teams just meet twice a week to chat about what each team's doing and get things together. We don't actually practice Scrum, we practice extreme programming, but stand-up of stand-ups never quite caught on, so we just call it Scrum of Scrums. We have some internal microservice guidelines. So it's unrealistic to expect that everyone on your team is going to get excited about microservices and they're going to go home and read a microservice blog every night for the next 3 months and become an absolute expert. There will be people who do that. There'll be lots of people who don't, and the only thing they know about microservices is what they heard in the iteration planning meeting or what they heard from their peer or whatever it is. So in order to make sure everyone's on the same page, we made a one-page document that says this is what our guidelines are for microservices here at Tyro. Between people reading lots of blogs, you might even get people who are both experts but have different opinions. And so having some kind of guidelines that everyone can agree upon and move forward in the one direction is a really good idea. I want to talk a little bit about asynchronicity, if that's a word. Asynchronous communication is the grease that makes microservices work. Without it, you're kind of just making, a kind of monolith that's distributed and gets all coupled together. So at Yao, Martin Thompson said this synchronous communication is the crystal meth of distributed software. And his way of explaining that was that it's easy and it feels good, but it's really bad for you in the long run. And why is it really bad? Because of a thing called temporal coupling. Temporal coupling is basically services depending on each other in time. So if your service is waiting for another service to respond, it's not autonomous. That means if part of your system does go down, then lots of other parts of your system aren't going to work. And you've just kind of cut out one of the main advantages of microservices if you do that. So the advice I give to people at work is if you can do something asynchronously, you should. That should always be your preference. And it almost ends up that the only time you should do something synchronously is if a person or some other system that we don't control is waiting for a response. Usually when it's a system that we control, we can change the design so that we're not waiting for a response. The thing with that is asynchronous and distributed transactions end up coming in. And basically, you should avoid distributed transactions at all costs. And I'm not just talking about the standard XA transactions. Anytime when you've got two services talking to each other and they're both going to make a change to their data as part of that communication, that's a distributed transaction. And you need to avoid that if you can. So if you've got some kind of synchronous thing going on and you've got data needs to be updated in more than one service, typically the way we would address that is by having all the data committed to one of those services, and then the data that needs to end up at the other service is distributed over to that asynchronously. But then when you go asynchronous, you get some problems as well. So within asynchronous communication, what you often end up with is on the receiving side, you've got some business state, and that's going to change. But then you've also got some queue state somewhere. If you've got messages moving through a system asynchronously, there's always a queue state, which is what messages have been delivered. So having those two things can play problems. There's two ways to approach it that I've thought of. I haven't practiced both of them. But one is a feed strategy. So that means you will get on the thing that's producing a message, you actually produce a feed. And that feed, while it keeps growing, it doesn't have any queue state in it, because anyone who wants to read the feed can read the feed. So it's up to the client to keep their own queue state. And because the client has their own queue state, and they're changing the business state, you've got those two bits of... We're running out of battery there? I don't know. Does it keep dropping out, or am I imagining that? Okay. If it gets too much, just tell me and I'll start yelling. Oh, super. So yeah, feed strategy is the queue state and the business state are both in the one place in the one transaction, so you don't have distributed. The other way to do it is if your queue state is on one side and your business state on the other, what you need to do is your business change needs to be idempotent. So if it runs a second time, it's going to do the same thing it did the first time. And often that just translates into you need to do duplicate detection of messages that are coming in. So if the same message gets delivered twice, that's fine. So then you can commit the business change, and on the queue state side, you only commit your queue state change after you're guaranteed that the business state change has happened. And then you can deliver that message multiple times if you want and know that it's safe to do that. So it's really important to help out your ops team, because when you start doing microservices, they're going to have a heart attack. So here's a bunch of things we've been doing. This one's a bit old before microservices, but it's definitely helped. It's something we've leveraged. So in the good old days, ops used to upgrade our software. They would SSH into the production boxes. They'd SCP the war over. They'd bring Jetty down. They'd copy the new war into the right place, and they'd bring Jetty up. And we had 10 applications, and that was all fine. Eventually we got to 100 applications, and you can't be doing that every 2 weeks. It doesn't work. So we built this thing called deployment control. It's basically a web application that operations can log into, and they can see all of our production infrastructure, and they can click into any VM and say, they can see what software is on there, and they can just click and say, upgrade this software to the latest version. So when they do deploys every 2 weeks, they basically don't touch SSH at all. They just go into this web app, and they just click a button and it upgrades. So that way we can upgrade 100 things every fortnight, and they're just kind of clicking. We even put an upgrade all button on there, so if there's 10 things on there, they just, and it all goes. Sounds dangerous, yeah, but it's been working. New artifact checklist. So the first few microservices we pushed in were terrible. They're terrible from the point of view of we built them and then we took them to ops and we said, here, deploy this. And they're like, what is this thing? You didn't even tell us you had a new artifact. We usually prepare for these things 3 months ahead. They're like, oh yeah, that's not great, is it? So over time we developed this checklist. It's basically a list of things that the dev team should be doing and following up before a new artifact can be called ready for deploy and then fully deployed. One of the things that's on that checklist really early is a meeting with ops, and it's actually got a defined agenda on there of about 15 items around where it's going to be hosted, what firewall changes you need. Is it talking to Rabbit? Is it offering REST? Is it exposing the internet? What security does it have? All kinds of things. So we use that to make sure that we're getting the requirements from ops that they have right up front, rather than getting something almost ready and they say, no, you can't deploy that there. Split that thing in two because the design doesn't work. Got a new artifact pipeline. It's basically just a Confluence page, but it means everyone can look at this page and see what services are being developed, what ones are in the midst of being deployed for the first time. Are there things that are blocked and why are they blocked? Who's responsible for getting it unblocked? all on one page. So that allows teams to see where their things are up to and allows management to see, are there blockages in this system that we need to address. Monitoring is really important, super important when you're going to do microservices, but you also don't want to spend too much time on it. You don't want developers putting heaps of time into monitoring because a lot of the time you're doing the same things in each thing. So we've got some common libraries we've written, and basically if you import these libraries and you've got a database, you instantly get monitoring for your database connection pool. If you're using Rabbit, instantly gives you monitoring for that. Whatever REST endpoints you're talking to, it'll find those and do monitoring and tell you whether they're up or not. We've also designed this thing in cooperation with ops so that the services are able to tell the difference between a warning and an error. So as an example, if I need a REST service, but there's 4 instances of that, and I know one of them's unavailable, that's a warning because I can keep doing my job. But if all 4 of them go down, that's an error because I can't do my job anymore. And that translates into ops world as, do I need to get out of bed? So if something says warning, it's like, I got to fix that in the morning. If something says error, I got to get out of bed. And I think it's really good when you're thinking about monitoring and alerting as a developer to put yourself in the shoes of an operations person receiving an alert at 3 a.m. in bed and thinking what information are they going to want, what kind of decision do they want to make, and how you're going to help them make that decision. Technologies and patterns. So I'm going to talk about a few things we've tried with mixed success. Pact is a testing tool for something called consumer-driven contract testing. And basically, it allows you to do integration testing, but kind of in a unit testing level. So rather than bring up multiple artifacts, you can do that unit test kind of phase. And the way it does this is you do a test on your consumer side. It has a mock server, and that mock server records what tests you did. And then you write tests on the server side, on the producer side, and it replays what those expectations were that were recorded. So you get a thing called test synchronization, where the expectations of the consumer are played on the producer to ensure it always does that. And the main advantage of that is backwards compatibility testing, because you're not limited to just playing the current expectations of your consumers. You can play the expectations of consumers in previous versions. So if you've got old versions of your consumers running in production, you can play them as well and make sure that your producer is still handling old versions of consumers. So you might have migrated your API, but you can check that you didn't break it for things that are still in production. So the original pact was written in Ruby by Real Estate Australia. There's also a JVM version written by DS. Both of those bring up a server during your test in order to work. We tried that for a while and didn't really like it, so we started writing our own thing based around Spring's mock MVC, which is an in-process thing. Basically does the same thing as the other two, but allows you to not bring up a server, which makes them run faster and it's quite convenient. Client libraries, they're an idea we borrowed from Netflix. The idea is pretty much that you take the logic for connecting to your service, and rather than putting that in each thing that's going to talk to the service, you put in a library, and each of those things can talk to it. It's got 2 benefits. You get code reuse, and you also, what was the other thing? Separation. So you get separation. So the services using the producer don't actually need to know how they're communicating with it. They get a Java interface. Messaging and event-driven and reactive stuff. So we had mixed success with this. As you would have seen, we're using RabbitMQ, and we've had some serious issues with that in production. Split brains, lost messages, really hard to get back from those situations. We're actually moving away from it at the moment. We've got a plan to move away from it. Some people are keen on putting another message broker in and trying some more. Other people are like, well, this message broker thing's not really our cup of tea anyway. My opinion is it kind of puts a single point of failure in a system that's otherwise really well decoupled. And I'm not sure that that's a good idea to put in something which, if this thing fails, everything stops, or almost everything stops. So there's differing opinions. There's also differing opinions on with event-driven. Should we be doing that as much as possible? So should we have no Rabbit commands on that diagram? Should everything be events? Anytime something does something, it just broadcasts it, and people react to events all over the place. So there's people who think we should be doing everything like that. There's people who think there's really only a small number of circumstances where that's applicable. That's something we're going to keep experimenting with, I think, and maybe we can share some more in another year when we've figured out what the best approach is. RxJava is another thing we've used a bit. It's a Netflix library for reactive streams. We use it in quite a few places, and we find in some places really useful. In other places, it made the code more complex than it needed to be. So I'd say this is something that you should really check out and have it in your tool belt, but be careful where you use it, because there's good problems for it, and there's problems where it's not much. Challenges. So host agnosticism. This is a bit of a funny one. It might actually be unique to Tyro, I don't know. Our applications can't be put on any host. The host has to have a particular host name. The configuration of that host name is in our source control. It tells it what to do. So sometimes those configurations per host are almost identical. Sometimes they're really different. Put the same artifact on a different host and it will do quite different things. It's a historical phenomenon, not something we started doing for microservices. But I just want to say, if you're not in this situation, don't get into it. And if you are, get out as quick as you can, because it's a world of pain and it's kind of hard to get out of. Deploy frequency and migration wavelength is something we challenge with. So we have 2 weekly deploys, which is great, a lot better than a lot of people have. But we also think it's not good enough. So often we have to do migrations because we're changing systems all the time. And your deploy frequency becomes the wavelength at which you can do your migration. So sometimes migrations have to be done over multiple deploys. You have to do step 1, this iteration, then step 2, then step 3. And having a 2-week deploy means that migration can take up to 2 months. And that's something that's got to stay on the team's board and they've got to remember to keep coming back to it. And at the end of 2 months, they're just going, what is this thing again? We've got to do this thing, but I don't remember why. Sometimes you don't need to do it across iterations. You can do it in one iteration, but you end up with some kind of deployment constraint. So we did this thing that's backwards compatible, not backwards compatible. So ops, can you remember to deploy this thing first and then that thing and then that thing? Because if you do it in any other order, we're going to lose $5 million or something like that. So those things are hard, and hard things are okay. But if you're doing hard things often, that's not a good thing. So we're actually got a team working on a continuous delivery pipeline for us that's going to get us away from that. So our deploy frequency will be whenever the hell we want to deploy. Architecture, evolution, governance. So depending on where you work, this might not matter much at all. We're a regulated entity, so governance is a word that gets thrown around a lot. Our architecture evolves a lot, and that's a great thing. We embrace change. But we have no official process governing how that architecture changes. So anyone can just go and change anything. And sometimes that means that weeks or months down the line, someone will go, oh, which team added this connection here? Because that really doesn't make sense and we need to back that out and do something else. So we're thinking about putting a lightweight process around that so we can figure out how to just get a bit more collaboration on that before those decisions are made or as they're being made. Client libraries versus Pact, the great fight of 2014. So Pact is great. It's for testing your REST interactions. Client libraries have been beneficial. They're for abstracting your REST interactions. So when you've got an abstraction, but we also want to test that abstraction at the consumer layer, we end up with problems. So that's something that's been hard. We've got some guys working on a solution to that now, which is kind of interesting. REST awareness. So a lot of people don't understand REST. A lot of people think if I send some JSON over HTTP, that's RESTful. You know, I'm using HTTP and I'm sending something I can read, and that's what REST is. So they miss the whole thing about it being resource-oriented, and they end up doing RPC just over HTTP. And that's not a good thing. You know, if you're all doing RPC over HTTP and you understood that's what you're doing, maybe that's okay. But when some people understand REST and some don't, you end up with this real mix of styles, and it can be quite confusing. So I just want to say, if you're going to start using REST, make sure everyone on your team knows what REST is, what it means. I think even consider not using the term REST. I think saying resource-oriented interfaces is really a better description of what REST is all about. Last challenge, Pact for messages. So we are moving away from messages, but in the meantime, we don't have any backwards compatibility testing for our messages, which is what we get from Pact. So that's something that's on our to-do list. We haven't got to it yet. We've got some ideas how to use Pact to achieve that. Lastly, I want to talk about an article that Martin Fowler wrote called Microservice Pre-requisites. And he started off with saying, you know, how tall do you need to be to do microservices? And he put in these 4 things. And he kind of presented them as a minimum for doing microservices. And in discussing them, he put some concessions in. So he said things like, it may not have to be fully automated to start with. But he wraps it all up by saying, with this kind of setup in place, you're ready for a first system using a handful of microservices. So my problem with this article was he had this picture at the top, and that's kind of what you come away thinking is you must be this tall to start doing microservices. And I think all those things he had are good advice, and you should certainly think about doing those things. Don't want to suggest that you should build a system of 20 microservices and try and throw that into production and see what happens. But at the same time, it would be really unwise to look at his list and spend a year building infrastructure to do that while delivering no business value. So what we've been doing at Tyro is continually shipping distributed software. It's more and more distributed over time, and learning from that and doing the things we need to do to deal with that, like building deployment control so that ops can deploy things faster, coming up with the checklist so that we make sure when we make heaps of new artifacts that they all get done right and people understand what they are. So yeah, I just want to say, consider those things, but don't be scared by articles like this and think, oh, it's too big a problem, we can't try it. You can try it. Build a microservice and get into production and see what you learn from that and get some feedback and adjust your own process. I got one last thing though. This is fun. Collective code ownership. So pretty much everything you'll read about microservices says what you need to be doing is you need to be dicing your services up by team. So that team owns this service and that service, and that team owns this service and that service. And there's even recommendations, if you've got a service that needs skills from multiple people, you need to make a temporary team and commandeer some people and give them that service, and then when it's finished, you take that service and you assign it to that team. Something like that. We don't do any of that. We have collective code ownership. It's an XP principle that basically says everyone's responsible for all of the code. Anyone can change any of the code. Now, within that, you'd be a fool to go and edit some service that you know nothing about without going and talking to the people who built it. You go and have a chat with them, you'd say, I need to do this, and what are the best ideas? But then once you've had a chat, you go away and you can change that code. And maybe you'll refactor some of the things they did and make it better. And that's part of the point of collective ownership, is that people make things better over time. So I don't want to say that we're never going to, give up collective code ownership, because maybe we'll hit some problems in the future and we'll get some feedback and go, we do need to dice these things up. But, I feel like we're being the rebels in that case, which is basically anyone can change any service. And that's going okay for us at the moment. So there's some microservice advice from other people, which I invite you to ignore. So wrapping up, Tyro's been on a distributed computing track for a long time now. In terms of microservices, I'd say we're still pretty adolescent. We've learned lots of things, but we've still got lots more things to learn. We try and stay informed and incorporate good ideas from other people, but we also sometimes ignore other people's good ideas and just kind of forge ahead and see what we learn anyway. And we're going to be doing lots more with microservices this year. We're hiring lots of people this year. So if you're a software engineer or a tester or a systems engineer or a network engineer, please come and see me and get a business card, because we want to get your resume and we want to see if you want to come and work for us and work on some interesting stuff like this. Thanks very much. People have questions? Yep.
So I know you guys use pair programming. How do you think that's impacted on the development of using microservices and going down that path?
How has pair programming is different? Yeah, I'm not sure how much I'd put that together with microservices, but the thing I would say about pair programming is if you look at the XP values, things like communication, feedback, respect, simplicity, and look at all the other practices that are in extreme programming, pairing supports almost every single one of them, and it's a multiplier for those things. So with pair programming, you get feedback 2 seconds after you've written a line of code. If you do code reviews instead, it's going to be a week. So 2 seconds to a week, that's a massive difference. And you can look at lots of things, and pairing enhances all those things. Communication's another great example. So I think some people think, oh, we won't do pairing, we'll get twice as much code out, and we'll still do kind of well. But I think pairing really enhances lots of agile things. So not doing it kind of divides the effect of your agile process. Is that an okay answer? Yep.
So, just a curiosity more than anything else. Considering the restriction that you have put in the technology stack to be used for having single microservice being Spring-based and using common libraries and so on and so forth, aren't you kind of closing the door to other languages or technologies that would allow you to solve a particular problem better rather than like, sticking to the same technology? For example, going towards a pass type of thing rather than forcing the same model by using the same technology stack?
Yep, good question. So the question is, by using pretty much the same technology stack for every service we write, do we cut ourselves out of using a technology that might be better for some process than something else? I think the answer is probably yes. I think we're not absolutely kind of committed to those things, but at the moment, things are set up really well to be able to produce a service that works like that quickly and get it in production. So if we wanted to start writing things in, say, Ruby, well, our deployment process is built around Jetty and deploying wars, so we need to do some work on doing that. And we can make that happen. And the continuous delivery platform we're working on is going to make some of that easier. So it's really built around base images and then what you're going to deploy on top of that. So we might be able to have, a Java version that makes it easy to deploy Java stuff and a Ruby platform that makes it easy to do that stuff. But at the same time, having lots of the teams working with the same technology can create real benefits from, this team solved a problem and 5 other teams get the benefit of it. So I think that's a trade-off, and we'll keep thinking about that trade-off. I think you make a good point. Some problems you're going to go, well, that really needs to be done with Haskell. So maybe we figure out a way to do that when that comes. Heaps of people have said that. I don't know if they've ever deployed it, but... Did you have a question?
I did have a question. I'm curious who owns or what the architecture process is. Who owns the decision to make a new service versus extend an existing one and so on?
Yeah, so that was who owns the architecture and who can make a decision about changing it. At the moment, basically the development teams, they're given a feature to develop and they'll sit with the product manager and come out with a bunch of stories for that feature, and they'll decide what changes do we need to make in order to make that feature. Do we need to change an existing service? Should we build a new service? And, there's kind of 2 types of features. There's features that are a new business responsibility, and that's obvious. We go and build a new service. There's other features that are kind of an enhancement to an existing business responsibility. And it's like, well, then you need to make a test. Does it just require a modification to an existing thing, or is it a big enough kind of change that we should put it somewhere else? And so that's kind of the problem, is that individual teams make decisions. And that's great. We love autonomy at Tyro. We love giving people the power to decide things by themselves. But with a regulator asking, how do you control these things? That's why we need to start putting some process around, not necessarily stopping that autonomy, but making sure there's some governance that kind of, checks that we have these rules for how the architecture can change, and are we following those rules as decisions are made?
I have a question about, do you have any orchestration in your services, or do you just have simple services, no dependency at all? Because sometimes in a big organization you have some sort of orchestration in your services as well. How do you deal with this stuff? Do you have any orchestration?
So sometimes we have services which, to achieve their responsibility, need to do some orchestration. So an example is we have a boarding service, and its responsibility is firstly to collect information from an application, and then once that application's been approved, it needs to go and talk to 5 other services to say, provision this guy on these 5 different services. So orchestration comes in when it's the responsibility of some service to conduct that.
So what technology do you use for that orchestration part?
So that particular example, it's a Java service. So it's already the thing that's collecting the information. And basically they have done idempotent REST calls and tracking. There's basically a state on that application in the database. So it tracks where it's up to, and it goes, for this state, I need to call that service. And if it succeeds, it updates the state to the next one.
If you modify the version for existing services, how do you control the interdependency between the services and the orchestration layer you got? So you got more complex services which which sit on top of your simple like microservices, and there's a deep interdependency between these services. How do you control this dependency? How do you say, I'm going to have a release into production next week, and so these are the dependencies, and we need to update these services as well. Do you have any control over that?
So I think you're asking how do we know we need to update the other things?
Yeah.
The answer is we have automated scripts that do our release. Every 2 weeks, anything that's changed gets released, and everything that's released gets deployed. And we have a thing that generates a deploy script, and that knows about the order of dependencies in terms of compatibility. And so it tells operations to deploy them in the right order so that backwards compatibility is maintained.
So more like a manual process.
The deployment has a lot of manual steps in it, but in terms of choosing what to deploy, everything's deployed. If we change it, it gets deployed. You've had one, I think.
Oh, actually, just add clarification.
Yeah.
The word ID coded a few times.
Yep.
So I found out what that word meant last year.
Yep.
Got a number of people, and they actually found out last year, so I actually asked them.
Yeah.
Maybe everybody in the room doesn't know what that word means.
Yeah, so I'll try and simplify it. Someone can tell me if this is wrong, because it could be wrong. It's basically, I'm going to call something that changes state. If I call it twice, the state looks the same as when I called it the first time. So as an example, if a transaction came in from a terminal a second time, we wouldn't pay the merchant for that twice. We wouldn't debit the card holder twice. We'd be able to recognise we've already done that. We wouldn't do it again.
You talked about how you never share databases and that you never have one service going to another to get data. So basically, you do replication everywhere?
No. So I didn't say we never have a service going to another to get data. We do that sometimes, particularly when there's a lot of data to get or when there isn't a time constraint. So if the thing you're doing is asynchronous, then sometimes you just go and get the data because no one's waiting. Does that make sense? Yeah.
There are certain like reference data and certain data like customer, which everyone needs.
Yep.
So do you replicate that as well, or
So
you will end up with some situations where you need this data instantly?
yeah. So the answer is we make a decision about whether to replicate that in each scenario. Typically, you do that if it was small, if it's 1 or 2 fields that you need, and it's something like customers, yep, you're going to replicate that because if you're going to rely on needing it, then you do it. If you need the whole customer object for some reason and it's owned by something else, you probably wouldn't replicate that because it's just copying a whole database into your database. And that doesn't make sense. If you get to that point, maybe you need to think about, have you got that responsibility in the right place? If it needs all that data, maybe the thing that has all that data should be responsible for what you're doing.
And if you decide to replicate, are you using Rabbit for that as well?
Yes, we are using that at the moment.
You mentioned that you never use distributed transactions. So did you mean across services or within services as well?
I think distributed has to mean across services. In my mind, that's what I mean. I say distributed, I mean 2 services. But we don't use any official distributed transactions.
I mean, there's a scenario that you described where you write something to your database and then you want to publish that as an event. So
Yep.
you enqueue a message. So if you do not have a distributed transaction there, then you might update your database, and then when it's time to enqueue a message, let's say it fails.
Yep. Yep, that's exactly right. So the way we do that is basically everything that we put onto Rabbit. Before we put on Rabbit, we save it into the database, and then we've got a thread that's pulling that stuff out of the database and sending it. And that's where we're using that strategy I was talking about, where it basically makes sure it gets an ACK from Rabbit before it deletes it from the queue. And if Rabbit has received it but doesn't ACK, we might end up sending it twice. So basically everything that we send over Rabbit has to have duplicate detection at the other end. So you're right. Sorry?
Is it like a batch thing that is running continuously?
Yep. Yep. So we call that our async Rabbit sender. So when you want to send something on Rabbit, you don't send it. You put in the async Rabbit sender, it goes into the database, and then comes back out onto Rabbit to guarantee that it gets sent to Rabbit.
Sorry, one last thing. You mentioned about feeds.
Yep.
When you said that, did you mean Atom feeds or?
We haven't done any feeds yet. There's a team working on it at the moment. I believe they're looking at Atom feeds. So there's some good talks on the internet about people using Atom feeds to do that kind of stuff.
So yeah, my question about how do you manage interfaces, contracts between microservices? Like if you have plenty of microservices and change one, you need to update every other one. And how do every team knows what these microservices do? Like that you have this existing functionality. Is it any process for this? Like
Yeah, so I'll take the second one first. So how do people know what microservices exist and what they do? That architecture diagram is really the go-to for that. By looking at that and having those artifact names that explain what each thing's responsible for, then you're able to basically look at the system. You should be able to get a non-technical person to look at our architecture diagram and they could explain to you what the system's doing. The first one was how we migrate APIs. So the answer is we use Pact to protect ourselves from backwards compatibility issues. And we have to do things in a way that is backwards compatible. So you talked about you update an API, you have to go and change everything that uses it. Well, no, you shouldn't have to do that. You should update it in a way that doesn't have to happen. And then you can update the things that are using it in whatever pace you want to. You could even leave them using the old version for a year if that's convenient to you.
When you start designing this microservices architecture, your starting point is really great. Like everything was fine, perfectly beautiful. Within 2 months' time, 3 months' time, new features come on board. Developers start working on things, and as you mentioned, like new request comes in, and developers start asking whether they have to do it in one service or another. And all the time, you may see a trend of change in each services, which in some instances it might make it turn it into a big ball of mud. How would you prevent that from happening? What sort of question do you ask when a developer or a team is going to change a service to make sure that it will remain as a service as it is, and the size of it won't grow over time?
Yeah, so I talked at the start about how we have one primary responsibility for each artifact. And there are sometimes corollary responsibilities. So that will be something that something naturally does. So as an example, if something was getting a huge batch of payments and then kind of crushing them up into one single settlement message or something like that, that'll be its primary responsibility. But then obviously someone's going to want to know something about that settlement message. And so we would have a corollary responsibility of reporting on, those clearing runs that it's done or something like that. So I think with your question about, adding things over time and that kind of thing, I think you want to be really careful about what's a primary responsibility and what's a corollary. You don't want something with one primary responsibility and 15 corollary responsibilities, because that would mean you're cramming stuff in. And so I guess you just want people to be challenging each other when they're talking about adding something into an existing service. Is that really that thing's responsibility? Or is that something that something else could be doing? Maybe it can be receiving events from that original thing every time it does something, and then he can do his thing over there. Is there another last question there?
You mentioned you want to move from messaging. Where to?
Feeds. So someone came and asked me about Rabbit the other day, and I said, it'd be really nice if someone tried out Atom feeds and tells us how that works. So there's someone trying that out now. We'll give that a go. The beauty of that is the components will provide their own feeds, so they're still autonomous in that respect. So anything that needs that feed can connect to it.
The packed stuff that's popular is probably kind of data sensitive. So because you're sending a request with certain data elements, you're expecting a response. So you have test databases that are loaded before you run those tests, or how does it work?
Yeah, it's a good question. So the way Pact works is there's a recorder in your consumer test, and it basically records everything you've done. So it records you did a GET request on this URL or these parameters. If it was a post, it will record the body, and then when you put in an expected response, which will usually be some kind of JSON payload, and it records all of that as a document. And there's actually a thing called a Pact broker, which is kind of like a Nexus. I don't know if people know Nexus, the Maven repository. It's kind of like that, but for Pact tests. So you can put Pact tests into that broker, and then when you run your provider tests, it's actually pulling those tests from the broker and running them from there. and you can put tags on those things. So we basically set up our production things, our producers, so that when a producer test runs, it automatically grabs the consumer expectations that are tagged with production, meaning they're in production now, and latest, so the ones that have been the latest to be written. So it's essentially...
It's changing, wouldn't the response change?
Yes, it does. Yep, absolutely. So expectations will change over time. You're talking about real data, because it's all test data. So you kind of need to figure out how to...
You have to freeze the data so that...
there's a few different ways of doing it. Some of them are like mocking, where you put in really detailed expectations. Some of them are more like a workflow. We'll chat more about it afterwards. Righto, thanks everyone very much. Thanks for your thoughtful questions.